Okay, welcome, and thanks everyone for joining the first EMEA demonstration of the new. Okay, welcome, and thanks everyone for joining the first EMEA demonstration of the new Snowsight user interface. My name's Anthony Schneider. I'm a sales engineer at Snowflake. I've been here for 2.5 years, having previously worked as a data engineer / data architect for the Nectar loyalty program in the UK. So I'm just briefly going to go through the agenda, what we're going to discuss today. So first off, what is Snowsight? Now, most of you have signed up for this webinar, so I hope you have some idea of what you're going to see today. Those thinking this is a forum to discuss interesting snow sightings that they've seen will be sorely disappointed. We're going to talk a bit about why Snowsight, so some of the business use cases that you might use the Snowsight UI within Snowflake around your business. We'll dive into some of the key features that have been written into the Snowsight platform, and we're going to finish that off with a practical demonstration where I go through some of those key features and actually use the user interface live. So, Snowsight is our interactive SQL editor with charts. Now, Snowflake, as you're probably aware, is very customer first. Everything we build into the Snowflake platform is from direct feedback from our customers. I spend a lot of time on calls with my customers, talking about the things they like about Snowflake, but more interestingly, I ask them, well, what do you think could be improved? What sucks in Snowflake that you'd like to see better? And this is direct feedback from them in regards to our existing UI, and they can really be into 3 key buckets as to how we've developed this user interface. The first being productivity. Now, with everyone working from home at the moment, you're probably spending a few more hours watching Netflix, and you've got less hours in the day actually running SQL. So we've spent a lot of time in making people more productive in how they write SQL within the Snowsight platform. Secondly, we have collaboration. So Snowflake's all about breaking down those data silos, having everyone operate on a single version of the truth within Snowflake. What our customers have said, though, is we want to collaborate even further. I want to be able to write SQL and share that with my fellow analysts around the organization. So we're really bringing in this idea of collaboration and sharing throughout the organization, both at a data level and a SQL and a code level. Finally, visualizations. So I'm an ELT or ETL developer by trade. I often didn't have access to the BI tools that the BI team within the organization had. So Snowsight's about giving those basic visualization components to the entire organization or every user of the Snowflake platform as well. So let's dig under the covers and just look through some of the features that we've built into the platform that I'll show you in the demonstration today. First off, we're looking at fast and responsive querying. So most people today aren't willing to wait 30 seconds for a coffee. We had to build a new UI that was very fast, very responsive, regardless of the volumes of data that we're querying. We've got some capabilities around smart autocomplete, which is very cool. I myself have an awful memory. I forgot my first wedding anniversary. There's no way I will remember the name of a column that a DBA gave on the customer table 3 years ago. So that idea of, within the context of what I'm writing in SQL, making suggestions to me within the UI is a very cool feature. Writing less SQL, everyone does date range picking when they write SQL against certain tables. So we've got some automatic filters out of the box that would allow you to just browse various dates of your data and start to query in that format. Interactive results. So I want to query my 1 billion row fact table, and I want that data to come back really quickly so I can start to explore it. So really fast interactive results, no matter how many rows are returned in the result. I can't have the UI hanging when I'm querying large sets of data. Now, automatic stats is a big one as well. So as you load and query the data, we're using all that rich metadata that Snowflake stores behind the scenes, and we're giving that back to you in a GUI interface so that you can start to understand some of the trends in your data. Are there a lot of nulls in this field, for example? So we're using that metadata very proactively in this new world. If we talk about the visualization components, we've got some beautiful, simple charts that we've added into the platform. So again, as I mentioned, lots of people in the organization, be they as an ETL engineer, could really benefit from being able to visualize some of that data as they explore it. And they could save a lot of time by being able to see quick visualizations of their data. So whether your organization has 10 people or 10,000 people, we wanted to put basic visualizations in the hands of every analyst that's using the platform. On top of that, we've got the concept of modern dashboards. So maybe I want to put multiple queries and multiple visualizations within a dashboard and share that around the organization as well. And finally, that collaboration, the idea of sharing those dashboards with my colleagues, but even sharing the raw SQL with my colleagues so they can benefit from some of the work I've done initially and then most likely improve on that in the future. So why Snowsight? What are some of the use cases you might use Snowsight for? So data validation is a big one. As you load data into the platform, you want to see, is the data as I expected it? So while in the course of loading, being able to write SQL and get some quick answers on the quality of that data. Exploratory queries is also another one. Now, this is a tool that people need to have some familiarity, or at least as a data explorer, have some familiarity with SQL. So it's a write SQL, produce charts, and those are the quick charts that we have. So the ability to get a chart up and running really quickly without doing lots of drag and drops and clicks, and being able to explore the data both at a textual level, but also at a visual level as well. We still have our rich ecosystem of BI partners as well, be that Tableau or Sigma or any of the big names out there that have really focused a specific niche on BI and visualizations. So where they still play a very important role in an organization, some examples might be institutional reporting. That is, I have a really complex dashboard with complex security requirements, complex graphics, maybe maps, geospatial. They need certain colors to adhere to their company scheme. That's something that the BI tools will invest a lot of time in, and that's probably a better tool to do those sorts of use cases. Business user exploration, I did mention that those using Snowsight will, at least the explorers, will need to have some familiarity with SQL. Now, the Tableaus and the Sigmas of this world have really built capabilities of drag and drop interfaces where an analyst can explore the data without actually knowing SQL. So there's probably some use cases in there that they're better suited for. Complex dashboards I've already touched on, but also the concept of embedded BI applications. So I want this complex dashboard embedded in the front end of my user website and white label that as my own. That's something that the BI tools are really focused on as well. So we work well in that landscape, certain use cases for our BI partners, and certain exploration use cases Snowsight should be capable of. So on that note, I'm going to switch to my screen and do a bit of a practical demonstration of some of those key features. Just be a second. And while that's loading, I'll just set the context of this fictional scenario that we're going to be building. So in this scenario, I'll introduce myself as Boris. I'm a slightly erratic SQL analyst who works for Transport for London. Now, Transport for London in this fictional scenario have built what our clever organizations are doing today. They've built a data lake where they've dropped a whole bunch of raw data into the Snowflake data platform. And they've promoted Boris and asked some questions of Boris to answer questions related to that public transport data that's all been dropped in the lake. Now, we've got a mixture of data within there. We've got some JSON data and some CSV data. Boris has also been asked to explore the patterns that are emerging from the data related to the Santander cycle scheme. Now, for those outside of the UK, the Santander cycle scheme, or Boris bike schemes as it's more locally known, is data related to the government-sponsored local bike hire scheme. There are a number of stations sitting around London where you can hire bikes, pick them up at a station and drop them off at another station or the same station. You pay by the hour for that privilege. Now, whilst this is a fictional scenario, the data I'm using here is real. So this is real data from that cycling scheme around London, showing all the trips and journeys that users are taking. So the new Snowflake user interface has a new URL, app.snowflake.com, easy to remember. And what you can see here is we've got some accounts that I frequently use. For new users to the URL, if you haven't logged in yet, you will just have to enter your account name down the bottom. So I'm going to click on my Demo 12 account. I'm going to log in as Boris. Okay, so this is the new user interface. So first off, we default to the worksheet tab. Those that have used the classic UI will be very familiar with this, but these are the worksheets that allow us to write SQL against the Snowflake data platform. We click on the left-hand side here, we've got this new dashboard tab. So we've got the ability to create dashboards and put visualizations or put raw data into a dashboard. Now, just to give you an idea of what Boris is going to be building today, he's been asked various questions around that Boris bike cycling scheme. Some of those around which are the busiest stations in the top there, a live view of the empty bike stations around London where there are no bikes available for hire, the average ride duration of some riders, and a chart which tracks the usage of Boris bike activity over a period in time. But we're going to build that out from scratch using an empty dashboard and add certain tiles to it later in the demonstration. The other tabs here, we have a discovered data tab. So these are the databases that are available to Boris within his access rights. So he's got the Boris bike scheme sitting within there. He has some data from Wikipedia and some sample data to access as well. On the right here, we also have the data marketplace. We now have a lot of public data sets that you can explore instantly. So I can suck in all sorts of random data from Snowflake partners and have that accessible immediately in the Snowflake platform. If you are interested in exploring the data marketplace in a bit more detail, we do have some webinars booked in for that as well. Finally, we have the admin tab, and we're going to touch on this a bit later, but I talked about that ability to write less SQL and bring in date filters with the click of a button and build your own filters on those dashboards. We'll show you that in action a bit later as well. So if I go back to my worksheets tab, we've got this folders tab as well. So great for organizing your SQL worksheets into various activities. And we've got one here for the Santander Snowsight demo. We've pre-populated it with some empty worksheets that we're going to populate today. Now, in order to create a new worksheet, we can just click the plus worksheet button here. By default, Snowflake gives that worksheet a date timestamp name, but we can, of course, modify that to Boris messing around. And then if we click back, we have to actually write some SQL up. There it is. So it saves that automatically. So everything's auto-saved behind the background. No need for me to hit the save button. So let's start to query some of that data that's existing within the TFL data lake. I'm going to start to explore some of that in the new Schema Browser. So if I click Schema here, immediately on the right-hand side, you'll see the new Schema Browser. These are all the data sets that Boris has access to. So he's got the privileges to at least write selects on all of these data sets. We have a mixture of data sitting in its raw format, in the raw schema. So in its raw, whether that be semi-structured or whether that be CSV data. But we also have some pre-built views that the DBA team built as well. That's sitting in the public schema that we can start to query today. Now, one of the cool features of the new Schema Browser is a really powerful search feature. So what we're able to do now is actually search for individual table names, but also individual columns within those tables. You can see how quick and responsive that is. By just typing in the word name, I've now got a list of every single field that exists within every single table, so I can start to explore the metadata related to all my data through that. It can also help me if I search for ID. There's no minimum length of that search query as well, so I can pick out all my primary key fields there that the DBA team have labeled with a suffix of ID. The other thing we can do is also, oops, just lost my mouse. We can also drag and pin certain tables to our worksheet here. So they're now pinned on this worksheet and they'll be there for the life of me querying the data. So that is handy to have that information available. Also, without even writing a query against this data, we display some of the metadata related to that raw data. So that trips table is a granular level table of every single Boris bike trip that's been taken in London since the start of the program. And that's a real life volume there. So there's been over 80 million trips of people riding Boris bikes around London. And you get a bit of a breakdown there of the various column types as well. So let's start to query some of that data and look at some of the other features. So straight away you'll start to see that we're contextually doing autocomplete on tables that I might be interested in querying. So straight away there we can see it's auto-completed the raw trips table. I'm going to select from the raw trips table. I'm going to choose a random start station ID. I'm going to hit Control-Enter to run that. We've also got the play button in the top right-hand corner there. Snowflake's going around, and I've mistyped from, so autocomplete didn't protect me from everything. So selecting star from that raw table, just to have a quick look at the data and start to explore all the data related to start station 519. And this is where I'll bring your attention again to the bottom right here and some of that rich metadata that we're displaying out of the box. So straight away we can see this particular station, which is in Poplar, has had 13,000 journeys taken in it since the start of the program. We also get some metadata related to the actual fields within this. So we can see that the rental ID field is 100% filled. That's good. That's good quality data. If there were any nulls in there, we would have seen some of those. You get a bit of a breakdown of the various dates. So we can see a lot of activity in 2012. It's gone down a bit, but we have a breakdown of all the dates of all the trips. And as expected, the start station ID 519 is the only unique value there. What is quite interesting here is that the start station name, which you would expect to be unique, is not. So this data is a little bit messy. So it looks like the actual name of the street is different for 188 records out of those 13,000. So they've used a colon instead of a comma. And if I actually click into that and then click on that 188 record table, you can see the UI has dynamic. We can see that these occur between 2012 and 2013. So perhaps in the early stages of the Boris Bike scheme, there was a bit of messy data in terms of the start station names. And that's the reason that we have some of that data. Now, what you'll also notice behind the scenes, we're not rerunning queries as I start to explore it using the UI. So everything within that 13,000 result set, we're just querying the cached result set. So we're not having to fire up compute and run queries even as we do a little bit of exploration. So we've done the sorting of results there. Another cool thing, if I clear that filter now and go back to my 13,000 records, the search tab is useful for searching the schema. We can also search the raw data as well here. So I'm going to type in Islington, which is near where I live. Straight away, it's searched every single record within every single column within the user interface. And there's only 4 riders who have taken what is a pretty significant journey from Poplar to Islington Green. They've all taken roughly a couple of hours to do that journey. So straight away, we're able to do a bit of analysis on the raw data without running 50 different SQL queries to get to that answer. Some of the other useful features that you'll find handy, just like in the classic UI, we allow a download of the CSV data, so we can download that 13,000 result set as a CSV. You can never stop some analysts from dropping that into Excel and using that. We support that. Also, another unique feature, if you're a bit of a messy SQL writer, up in the top here, we can click and actually format the query. So if you're sharing your queries and you want to pretend that you're a neat SQL writer, this has gone in and passed all the SQL that I've written within this worksheet and made it nice and pretty. I like my messy way better. Last thing I'll mention when we're talking about metadata and that using that rich metadata as we query data, this is CSV data that I've been querying here, so it's structured data. What I'm going to do is query a semi-structured table. In this instance, it's a weather table. And this shows an hourly pattern of weather that's happening throughout London at any given point in time. So that's JSON in its raw format. We haven't done any transformations as the DBA team has let that in. And what you'll see is that we automatically break down the data into the various elements within that JSON document. So some information around the city, the clouds for that hour, the time of that hour, and some other factors. But what's also very valuable is if I click on the variant column here, we do a full breakdown similar to what we do with structured data with semi-structured data as well. So whilst every single hour of data has a city field for this 1,000 hours of data, as you would expect for weather data, only 37 hours of those 1,000 hours have a rain a rain element with them where they're tracking the amount of rainfall. Now, being in England, I would sort of expected that to be more closer to 999 days or hours of 1,000. But we can see here that only 37 hours of these randomly selected 1,000 hours actually have a rain measurement. And sunrise and sunset, of course, only happens within 1 hour each day. So we're only seeing roughly one record per day for sunrise. So it's a good way to query some of that metadata within the semi-structured data. So the question Boris was trying to answer here was the busiest stations. So we can just do a quick start station name, count star from raw trips, grouping by 1, ordering by 2 descending. I'm going to limit that to the top 10 stations. So again, it's gone back to that 81 million row table. And no surprise, King's Cross, big commuter station, over the life of this program is the most busy station. But then Hyde Park, which is probably more leisure journeys, is second on the list of 676,000 hires within that system. So we've already answered question 1. Now we're just going to switch back and do a more complex query around trips increasing over time. So again, just going to run a quick select on that raw trips table so we have the data available. Bring in 100 records. I'm going to start to visualize some of this data as well now. Now, when we're talking about trends over time, the start date within here is actually a timestamp. So that would get us a trend of every minute over time. Now, I always remember one of the problems I have is, again, being quite forgetful, is there are a lot of rich analytical functions within Snowflake, but I often forget what those are. What we now have is that autocomplete function extends to the analytical functions as well. So I knew that the start of that syntax is date trunc, but it also is going to tell me what the inputs to that analytical function are, which I often forget. If I want to read a bit more information, I've got a direct link to the Snowflake documentation as well if I want to read more detail on how to use that. So that's really powerful and will save me a lot of time having to go into Google and search for analytical functions. They're right there within the UI. So I'm going to truncate this down to a day level. I'm going to use the start date again. And we will group by 1. We'll do this for the entire 81 million trips. So I didn't do a count star. Very important. Okay, so now if I click on immediately the keen eyes here will notice this data isn't entirely clear. And that's even more emphasized when I quickly click to the chart. So you'll see out of the box, I'm getting not the chart I expected here, and that's due to some data inconsistency problems. If I cruise down to 1900 here, there were roughly 38 or 10 bicycle hires in 1900. Now, it's pretty safe to say that there were no Boris bikes in the year 1900. So straight away, I'm able to, in this example, I'll just hard code those out and say where the start date is greater than, let's say 2010. And that looks a bit better. Now, what we can already see straight away again is those seasonal patterns over time. So Snowflake's made some default selections based on the data. You can start to see the summer, winter trends, so up and down, up and down. So straight away, we're starting to get some valuable insights. Now, if I just click on the field on the right-hand side here, we also have this ability of bucketing out of the box on date fields. So if I click on date, we can see, it's auto resized it there. This is a day-by-day view of so this is the raw data that's coming out of the box. So straight away, we can see some peaks and strikes again, but we actually see this big uplift on July 9th, which again gives me insights that perhaps this is a data issue or perhaps not. We also see some interesting values happening towards the end here as well. Now, when I was running this yesterday, I was interested in that spike. It seemed like a huge number of bicycle hires on July 9th. 72,000. So I could go in and search the data to see if there's any duplicates. What I also did, though, was those keen eyes in the Schema Browser would have seen that I had the Wikipedia database within here. So there actually is a page within Wikipedia that shows all the big events that happened year by year. I run a quick select star for July 9th. I can actually see that on July 9th of 2015, there were tube and train strikes causing travel chaos in and around London. So again, I'm saying that is actually a correct data from my mind, because there was a tube strike that day and everyone was riding their cycles. So already done a bit of dynamics work on that. I'm going to change that back to a week bucket. I think that's a prettier visualization. Finally, I want to drill in a little bit to these recent trends over the last couple of years. I don't want to rewrite the query and hard code it like I did before. So what we have out of the box is some unique filtering capabilities on date ranges automatically. So I'm just going to change my where filter to equals a date range. Now this is a filter that everyone has by default, because Snowflake's very aware that everyone runs date range filters on their data. And I'm just going to run that. You'll see what's dynamically popped up in the top left here is a filter. It's actually saved based on the last time I ran this, so it's actually defaulted to the last 2 years there. But now if I wanted to elongate or shorten the date range within that chart, I can just plug in a value and look at the last 3 years, or I can look at the last 7 days, last 12 months, whatever it may be. Click apply. Now we will rerun the query then. I'm now looking at the last 3 years of Boris Bike cycling data. So if we look, we can see those seasonal trends again, up and down, but also we get some interesting stats closer to the year 2020. So where we expect an upward trend, it's probably no surprise to anyone that down on March 23, the Boris Bike scheme had one of the lowest recorded usage patterns of Boris Bikes in its history. And I don't probably need to tell anyone what that was about, but March 23, if my history gets me correct, was the date we went into lockdown. So very few cycles that week, but users got a bit restless in May. I think we had a very hot week that week, and we've gone right back up to 273,000 unique trips in May. So very easy to bucket those to make the charts more clear, but also very easy to add a dynamic date filter that we can just click and change at will. Now finally, in this fictional scenario, Boris is a bit of a Chelsea fan, so we're going to tie multiple data sources together to analyze some of the activity of people riding to Stamford Stadium and some of the Chelsea games. So I'm going to use a few different data sources here. I'm going to use my trips data. We've got some data related to Chelsea games, we've got some data related to the stadium geographical locations, and we'll use our station list as well. Now these stadium geo and Chelsea games, we can click the preview button just to have a quick look at that data. Again, this is ripping a whole bunch of data out of the Wikipedia database and getting me the longitude, latitude stats of every single stadium in the world. We also have some data that we've ripped from the Chelsea results page within Wikipedia that actually breaks out the home team, away team, the attendance, and the time of each match for each Chelsea game. We're going to tie that data together to look at some of the bike riding activity of the Chelsea fans. Now, I've pre-written this query. Just going to resize the window so you can see it. I won't explain it in too much detail, but it was a bit too long for me to type out during this session. But effectively, we're joining that raw trips data to the station list. Now, the reason I'm doing that, I'm joining to the start station and the end station. That's to get the latitude and longitude of both the Boris Bike docking stations that the users have gone from. I'm joining to that Chelsea 2018 games table. I'm saying where the end date of the cycle journey is between the match timestamp start time and 2 hours before the start time of the Chelsea game. I'm also cross-joining to the stadium's geographical locations, filtered on Stamford Bridge Stadium. I'm also using this geospatial function, Haversime, which will only show me end stations that are less than 1 kilometer from the end station latitude, longitude to the stadium longitude, latitude. So it's going to get me all the journeys that ended within 1 kilometer of the Stamford Stadium. I'm just going to run that. So again, that's joining those 81 million records to all those other various tables. And Boris wanted to see, okay, who are the most dedicated Chelsea fans that have ridden a very long way on the Barclay bike scheme to the games. So you can see here one keen fan has ridden 12.6 kilometres. Anyone who's ridden the Boris bikes know that that's a pretty decent travelling distance to travel to a Chelsea game. And he or she has ridden all the way from Canary Wharf to the Helford Road station, which is right near Kensington Station. But one of the other features I want to touch on here, so in our select statement here, we're building a dynamic URL. So the new UI allows for the ability to link to third-party websites. And I'm dynamically constructing that based on the start station latitude, longitude, and the end station latitude, longitude. So I now have a clickable link, which I can click on. And that's taken me to the Google Maps UI. And I can now see the exact journey, or at least a representation of that journey that person's taken from Canary Wharf all the way to the game. Zoom in a bit further, you can probably see Stamford Bridge Stadium right there. So he's found a station very close to the stadium and has made it in time for the game. He actually arrived an hour and a half before, so time for a pint. Some of the other interesting stats in there, we can see there's a creature of habit. So straight away, there's someone who's riding from Bethnal Green for every single game and obviously has a stadium that he quite likes. A station that he quite likes. So every game he's ridden to the Imperial Wharf station from Bethnal Green, which is a 10.5 kilometre ride. So a very keen Chelsea fan there. So finally, we want to share some of this data into a dashboard to share with some of Boris's colleagues. So how do we do that? What we can do is move this query to that empty dashboard. This is one way to populate the dashboard. So I'm just going to click move to the empty dashboard, confirm the changes of that move. I'm just going to return to the dashboard. You've got a bit of an option to rejig that query if you want to. Now, by default, it's added the chart because most people who are dashboarding add the charts. Now, the chart doesn't make a lot of sense here. So what I'm going to do is I'm going to unplace that tile, show you another way to add tiles into the dashboard. We click the plus button in the top left corner here. We can actually add, drag and drop some of those queries that we wrote earlier. So I'm going to drag in the busiest station tile. It's automatically going to format that. I'm going to drag in the live empty stations tile as well. Now we do some quick auto formatting. I'm going to place that next to that one in the top row like we saw in the demonstration. The average ride duration, we're going to drag and push that into the top right. Finally, we're going to add those latest two that we did, have the trips increased over time. And finally, our dedicated Chelsea fans, but this time we're going to add the raw data. We'll put that down the bottom there. So there are some basic formatting options as well if you want to elongate and extend these. But great work, Boris has created his dashboard. Now, some of his colleagues would benefit from perhaps contributing to this dashboard and making it a bit better. So what we're going to do now is share this dashboard and the raw SQL that sits behind it with one of our colleagues at TFL. In the top right corner here, we have the share button. I'm going to search for a user within here. So one password. So we're going to share this with Kia, who works at TFL as well. We get to choose what privileges Kia has over that dashboard. So we can just show them a view of the data. We can allow Kia to run the dashboard, but also we can collaborate and allow him to edit and change the dashboard if he wants as well. So I'm going to allow him to contribute and edit on that dashboard. I'm going to quickly change personas now and switch across, pretend that I'm Kia logging into his account. So he hasn't logged in before, so I just need to remember that. He's got his own credentials. Now, straight away, Kia is presented with his user interface and the sheets that he's been working on. But also now, if we click on dashboards and we click on the shared with me, we can see that dashboard that Boris shared with me 1 minute ago. If we click on that dashboard, we're now getting a real live representation of the chart that Boris built. Now, we're now running short on time, but I'll just try and brush through a modification that Keir wants to make to this. So Keir thinks this is very valuable, seeing that the average duration of a journey is 8 minutes. But Keir's decided, no, I think people want to drill down a lower level. They want to see the average duration of a particular station. So if I click back to the main window now and go to our filters tab, I can create my own dynamic filter. We'll call this station name. We need to give it a keyword. We'll call it station_name. Just leave the description blank for now. Because this is populated based on other data, we need a virtual warehouse to run it. We then need to write the query, which is select the distinct station name from public.stations. Now, the reason autocomplete wasn't working is I need to set a context. If I click run, just to make sure that I've got my syntax correct. So we've now created a unique filter for all the station names, the Boris Bike station names. What we can do is refresh that hourly. We can say the users can select multiple values. We can include an all option if they do want to see all the values. Click save. Now that's one part of it. Now Keir's going to need to go back into the dashboard and actually edit the query that Boris wrote. So he's going to have to say, and the start, oops. Sorry, I just dropped out for a moment there. I think I'm back.
Yes, you are.
Thank you, Emma. Behind the scenes, Keir made that adjustment to his dashboard. He's going to rerun the dashboard to make sure that, oops, maybe he didn't make the adjustment. Oh, sorry, my Wi-Fi didn't save that, so I'll just go in and quickly make that adjustment again. So we can now see that new filter that Keir's added, and we can dynamically choose the Hyde Park corner, which was already selected. And you can see now that the average ride duration has changed specifically for Hyde Park. We can see that the average journey within the Hyde Park bicycle station is actually 23 minutes. So people riding from Hyde Park are riding longer journeys than people on average over the Boris Bike network. Finally, I'll just switch back to Boris's window. He hasn't refreshed his browser, so he hasn't got Keir's adjustments yet. But if he clicks refresh on his browser, we've now got Keir's collaborative new filter in his chart because he gave him those edit privileges. And Boris can now benefit from that work that Keir's done and start to apply dynamic filters himself. So that collaborative way of sharing SQL, but also collaborative building of dashboards is quite powerful as well.